G'day everyone, so in this we're going to be finding limits of functions. So you need to remember when you are working out limits, it's just the behavior of the function or what it's going to at a certain point. So with this, we just need to think of x going towards a spot and what's actually happening to the function. So what y value is it going towards? So that's probably the best way of thinking about it, is what it actually approaches to that point. So that's the whole point of limits, is just seeing what value it approaches as it's going to that value. So normally we have as x is approaching as all these examples. So that's the best way of doing it, and we'll just get into some of them and hopefully you have a good understanding of it afterwards. So firstly, with this one, the first one, the limit of 15 as x approaches 3. You might be looking a bit confused because we don't have an x value to actually put into this. So what it actually is equal to 15, because it doesn't matter what x value it is, it's always going to equal 15. So we can't substitute an x value in, so the limit as x approaches 3 is equal to 15. So now we've got the limit as 3x minus 5 as x approaches half. So what we need to do here is you just substitute the value of half in, and we'll see what value we get to. So 3 times 1/2 minus 5. So this becomes 1.5, or 3/2 minus 5. And then this will equal negative 3.5. Okay, so that's what's happening to, that's what the y value is as x is approaching a half. It's approaching negative 3.5. So this is what's going on here. Now the one below it, this one's actually a tricky one, because if you do read this down here, and I just had it for this purpose, this is where we've got two limits on each other, so we can work them out on the top or bottom. But gx, the bottom one, can't equal 0. So if we substitute negative 1 into the bottom, the denominator there, negative 1 plus 1, that's equal to 0. So this one actually doesn't work out at the moment. But we can actually break it down and eliminate this t plus 1 on the bottom by factorizing the top. So whenever something doesn't work out, especially with this quotient of the limits, it's always good to see if you can factorize the top and eliminate the bottom. Okay, so that's what we're going to do now. So the top actually factorizes to, so we're going to change this. This is going to equal to the limit as t approaches negative 1, and t squared plus 2t plus 1, this actually factorizes to t plus 1 squared. So I'm just going to write it like this though, t plus 1 over t plus 1. So now we can actually cancel out two of these. Okay, so this actually just leaves the limit as t approaches negative 1 of t plus 1. So we substitute this in, so negative 1, so it becomes negative 1 plus 1, which is equal to 0. So that's how we actually work out this, and this is probably the trickier ones of them, is when you have the quotient and the bottom function can't equal 0. Okay, if it does equal 0 and there's no way of factorizing it to simplify it, we actually say the limit doesn't exist. So that's one way of looking at it if it doesn't work out. And then finally, we've got this value over here. Just because it's a square root doesn't mean it's any different. So we substitute our value of 9 in for x, because we're looking at what happens when it approaches 9. So it becomes the square root of 9 plus 3, which is equal to the square root of 12. And we can actually simplify this down further, because just remember Square root of 12 is the square root of 4 times 3, which equals 2 root 3. So that's what the limit as x approaches 9 of the square root of x plus 3. So recapping, limits is just seeing what's happening to a function as it approaches a value. So what the solution to it is as it is approaching that value. And just watch out for your quotient ones, like in this example. You can go back and look through it again. So the bottom value here can't equal 0. And if it does equal 0, the limit doesn't exist, but you can or might be able to cancel it out using some factorization. Okay, so that might be somewhere where you might be able to cancel it out. So hopefully this helps, and good luck.